Now an example, let's expand x plus 2 all raised to the power of 5. Now, for each of the coefficients, I could use the numbers in the correct row of Pascal's triangle. I know it's the row that's going to start with 1, 5, because I'm raising to the power of 5. But I'm going to use my N's use R numbers this time, just to show the way that we can use that general rule. I'm also going to write out every term really carefully. Now, you'll notice that when you've done this for a little while, there's some terms you're not going to bother to write down. For example, 2 to the power of 0 is just 1. And so if I've multiplied 1 by these other parts, I'm not going to need to write that. Similarly, like up here, I've got x to the power of 0. But there is some value in writing the whole thing out, especially when you're learning, because it's a really good check. I can double check here that the powers each time add up to 5. So for the x's, I've got 5, 4, 3, 2, 1, and 0. And for the 2's, I've got 0, 1, 2, 3, 4, and 5. And a quick glance tells me that I haven't messed anything up or left anything out. I've also got my 5 choose 0 all the way up to 5 choose 5. So a quick inspection here tells me that this is a great first line of working. On the next line, I can think about what each of these numbers will be. So 5 choose 0, there's only one way you can choose 0 things from 5. So I know this is a 1. This is also a 1, so I can hop straight in here to say this is x to the power of 5. 5 choose 1 is 5, but I've also multiplied that by the 2. So 2 5s are 10. So my next term is going to be 10 x to the power of 4. Now 5 choose 2 is 10, and 5 choose 3 is also 10. And thinking that through just saves me a little bit of time. If you're punching it into your calculator, noting the ones that are equal to each other just cuts your work in half. So here I've got 10 multiplied by x cubed multiplied by 2 squared, which is 4. So I can see I've got 4 tens, which is 40, and then I've got my x cubed. So 40x cubed. And I think you can appreciate now how when we get numbers in our expansion as part of the power section, it means that the coefficients we end up with when we're finished won't actually be looking like a row of Pascal's triangle at all, but it's these numbers here that will. All right, so the next term we're up to here, this is a 10, and I know that 2 cubed is 8, so 8 tens is 80, so that gives me 80x squared. And 5 choose 4, that's the same as 5 choose 1, which is 5, and 2 to the power of 4 is 16. 5 16s is 80, put that in your calculator if you need to, or work these parts out in your head if you like. And now we've got 80 times x to the power of 1, so that's just 80x. And then there's only one way you can choose 5 things from 5, so we've got 1 times 2 to the power of 5, and 2 to the power of 5 is 32. So that's our expansion finished. For the next example, let's do one that's almost the same, but instead of x plus 2 raised to the power of 5, we've got x minus 2 raised to the power of 5. Now, something to bear in mind is that when you've got a negative number and you raise it to an even power, you'll end up with a positive number. For example, minus 2 squared is still 4. But when you raise a negative number to an odd power, you'll end up with a negative. So what we're going to find is that all of the numbers in this expansion are going to be just like this one, but some of the signs are going to be different. Now, this is a good shortcut to know because it can help you a little bit, but I still recommend writing out this first line super carefully so that you can consider each term and make sure you don't make any mistakes. So here, if we've got negative 2 raised to the power of 0, then that's going to give us 1. So 1 times 1, we've still got our x to the power of 5. But here we're raising our negative 2 to an odd power, and that's going to give us just negative 2. So instead of having 10x to the power of 4, we're going to have minus 10x to the power of 4. On the next term, we're raising our negative 2 to an even power again, so it will give us the exact same thing as it did up here, where we had 4 times 10. So we'll have our 40x cubed, and it will be positive. And now you'll notice something. Every second term is going to be negative. Spotting patterns like this really helps. The next one we can double check. Sure enough, negative 8 times 10, it's going to be minus 80x squared instead of plus 80x squared. Then we should have plus 80x, and the last one should be a minus. And double checking, sure enough, minus 2 to the power of 5 is negative 32. Now, this example is a bit trickier because both of the terms in our binomial expression are a little bit more complicated. So I've started with the same line. I've taken care to write everything out really neatly. I've got 4 choose 0, 1, 2, 3, and 4. And then the other two parts I've raised either the 2x or the 1/3 to either increasing or decreasing powers. And at a glance, I can check that those powers in each case add to 4. Notice how I've used brackets to raise each thing to a power. The thing I want to be really careful of here is to make sure I raise my 2 to those powers every time. Now, you can take a line to just jot down each part here and then tidy it up for your final answer, or you can do more of the thinking in your head. It's up to you. If you want to do it in your head and you're good at doing it that way and you don't make mistakes, go ahead. If you find that you make mistakes quite often, then take that extra bit of time to be sure of yourself. 4 choose 0 is just 1, and so I can sort of ignore that part perhaps, and anything to the power of 0 is also 1. So here I've got 2 to the power of 4, that's 16, and I've got x to the power of 4. So the first term comes out like that. For our next term, 4 choose 1 is 4, and if I want I can actually just generate my row of Pascal's triangle so that I know ahead of time what all of these coefficients are going to be. Jotting that down in the margin or something is often useful. So I know I've got 4 here, and then I'm going to have 2x cubed, and 2 cubed is 8. So straight away I can see I've got 4 8s, that's 32. And then I've got 32x cubed, and I'm multiplying that by a third. So I've got 32x cubed multiplied by a third, which I can write like that. Now again, if you prefer to write this out, even jotting it down as working above, to say I've got 4, I've got 8x cubed, and I've got a third, you could put all of that on this line here and tidy up on the next line. Up to you how you set it out. For my next one, in fact, I quite like that method of writing just above. I've got my 6, and then I've got 2x squared. Well, that's 4x squared. And then I've got multiplied by 1/9 because I've got a third squared. So that gives me 24x squared on 9, which I can simplify. I can divide by 3 here and divide by 3 here. So that should give me 8x squared on 3. Now for the next one, 4 choose 3, well that's 4. Multiplied by 2x, I can do that in my head, that's 8x. Multiplied by 1/3 cubed, that's 1/27. So I've got 8x multiplied by 1/27, which I can write like that. And if the last one, 4 choose 4, that's just 1. And this term here will just be 1. So I've just got 1/3 raised to the power of 4, and that is 1/81. And I'm finished. I can leave my answer just like that.